All right, so as we've done in the past, we are going to make a graphic organizer today. At this point in the unit, we've done a lot of different solving strategies for exponential equations and logarithmic functions, and we're at the point where we're going to be looking at them all together on one page, and it's like, wait, what do I do for this one? What do I do for that one? And this graphic organizer is designed to help you make those decisions, to help you decide, oh, this is the one where x is in the exponent, so I have to do this, that kind of thing, right? So it's called Solving Strategies for Logarithmic and Exponential Equations. And again, I kind of just mentioned it. We're really worried about where is x, right? First, we're worried about if we have a log or an exponential equation, and then it's like, where is the x? Is it in the exponent? Is it in the base? Is it in the answer, right? And that will help us determine which of these strategies to use, right? So we're going to start with this one, which is rewrite in exponential form, right? So rewriting in exponential form, that's when we're talking about going from like base to the exponent equals, well, actually, we would start in log base answer equals exponent, and we would change it to base to the exponent equals answer, right? So rewriting means you have this, turn it into that, right? So when do you do that, okay? What do we want to look for? Well, we want to look for, and most of the time what we're looking for is, whoa, it's way too big, is x, right? Where is x, right? And when we're rewriting in exponential form, x will be in one of two places. It will be in the base, or it'll be in the answer. All right, so one of those two situations, it's going to be either or. Okay, so we'll look at an example from each of those and we'll go from there. Okay, so here we go. And you'll notice in each of these I put like where is x, so we're really focused on where is x, right? And if I'm looking at this, right, well, remember it's log base answer exponent. Well, where's the x? It's in the base, right? So our x in this situation is in the base, and this is one of the scenarios where you would rewrite in exponential form. So I would think, okay, my base is x, my exponent is 3, and then my answer is 512. So it's okay. I've rewritten it. Now what? Well, now you got to remember how to solve this, right? We know how to solve this from our last unit. If I have to the third, I just need to do the opposite of that, which would be raise this to the 1/3 and raise this to the 1/3, otherwise known as taking the third root. And when I do that, this to the third to the 1/3 cancels. I get x equals, on this side, 512. The third root of that is 8. And there's your answer for that one. Okay? So again, x is in the base, so I rewrote in exponential form. Another scenario where you would rewrite in exponential form. So you get this problem, and you're like, where's the x now? Base, answer, exponent. Well, x is in that answer part, right? So if we're answering this question, x is in the answer, right? So if it's in the answer, same strategy. Rewrite it, see what you got. So here, my base is 2. My exponent is 3. And then that equals my answer of 5x minus 17. Okay, well, now I look at what I got, and I can do this equation, right? Because I can just solve for x. 2 to the third, I can find that out. Turns out that is 8. 8 equals 5x minus 17. Just have a two-step equation here, right? So I'm going to add 17 to both sides. I get 25 equals 5x. Then I would divide by 5, and I get x equals 5. Okay? And there's your answer. Okay? So those are your two scenarios where you just go right to rewriting an exponential form and you solve from there. Okay? Our next situation, or our next strategy, is the commons, right? So common bases or common logs, right? Common bases is if, like, for example, you might have like log 5x equals, I'm sorry, that's common logs. Common bases would be like 4 to the x equals 4 to the 5. Well, if 4 to the x equals 4 to the 5, x must be 5. Common bases, right? And then common logs would be if I have log base, any base, doesn't really matter, and then I have x equals log, and then it has to be the same as the first base, and then I had like 3. Well, the only difference between these is x became 3, so x equals 3, right? These are our common situations, right? Common bases or common logs. So what do I look for common bases or common logs? Right? So for common base logs, you would look for logs on both sides of the equal sign, right? And then you also have to have the same base. Okay? That's for common base logs. Now, common base exponents, well, now we're back to where is that x? And the x, in this case, will be in the exponent. And we also need to have common bases, common meaning the same, and I'm going to add a little piece here, or close. Well, what do I mean by close, right? Close, well, if I have like 2 to the x equals 4, well, they're not the same base right now. But it's pretty close because 4 can be rewritten as 2 squared. And then it would be the common base, right? So sometimes you need to do a little rewriting, right? And we'll do examples here, okay? So our first one, I have logs on both sides, same base, and 2 different answers. So the only thing that changed is this, and on this side, I had this, right? Because that's the case, they are equal to each other. So I just say, okay, I know a property that says, therefore, 4x minus 7 must equal x plus 5. And then I just solve that. This is a multi-step equation, variables on both sides. So I just get my x's to one side, my numbers to the other. All right, so I would move my x's to the left, so that's minus x. That gives me 3x minus 7 equals 5. Then I would add 7. That gives me 3x equals 12. Now I just need to divide by 3, and I get x equals 4. And I could check my work, really for any of these, right? But you can always check your work, plug back in 4, and you should get the same thing in both situations, right? Okay, so, oh, and where was the x? In the exponent. All right, so that was your common base logs, and this is a good example of our common base exponents. Remember I said they have to have the same base or be close, and I see 2 and 4, and we just talked about that 4 can be rewritten as 2 to the something, right? Therefore, they're close enough, right? So the first thing I got to do is rewrite them as with that same base, right? So this will just come down, 2 to the x, and then this, instead of 4, I'll put some parentheses, and I'll rewrite it with a base of 2. So that's 2 squared instead of 4, right? That's what that becomes, right? So this becomes that, right? Let's go green. That becomes that, okay? Now, the rest of it doesn't change, so I'm going to bring that down to, I have 2x plus 1, okay? So I've got common bases. Now, power to a power is what is an exponent to another exponent. It means I multiply. So I multiply this by this, but this by this, like the whole thing. And that looks like this. 2 to the x equals 2 to the this times this, so that's 2 times 2x plus 1. The whole thing, meaning I need parentheses. Okay? Now I just distribute that 2. I get 2 to the x equals 2 to the 4x plus 2. And there we go. Now we have our common bases, right? So I just say, okay, if this is 2 to the and this is 2 to the, then these two must be equal, right? So I can set them equal to each other. I say, therefore, x equals 4x plus 2. Get my x's to one side, my number to the other. So I'm going to move my x's to the left. Minus 4x, minus 4x. I get negative 3x equals 2. Got to get x by itself, so I divide by negative 3, divide by negative 3, and that gives me x equals negative 2/3, right? And I can plug that back in, make sure it's true, okay? So there's your second scenario. You got common bases and common logs, okay? Now, there's your third strategy is taking the log of both sides, all right? So if you're taking the log of both sides, this is something you would do. Again, we're looking for that x, and remember, over here, it was x was in the base, x is in the answer. This was the common situation. This is no common situation, right? But we have x, and where's the only other place it could be? In the exponent of either the log or an exponential equation. Okay? So it could be either of those situations, right? Now, we wouldn't need this if we had a common base. So we could also say, but no common base. And by the way, it would work even if you had a common base. You just wouldn't need it. Okay? So let's look at the situations we have here. Okay? Remember we said this could be in a log or exponential, so we'll look at both. Here I have a log, right? I got my base, I got my answer, I got my exponent. Well, x is in the exponent. So sometimes, like we talked about, that first strategy is rewrite in exponential form. Well, sometimes even that strategy is going to be inside another strategy. So even though we are going to take the log of both sides, we have to do that first. So we're going to rewrite in base to the exponent equals answer first, right, in that exponential form, right? So that's 2 to the x equals 10, right? And why do we need this? Well, I don't know any 2 to the anything that equals 10. Not off the top of my head, right? 2 squared is 4, 2 to the third is 8, 2 to the 4th of 16, none of those are 10. So our strategy for this is we take the log of both sides, right? So this, I'm going to write it twice. You can add the logs right there. But what I'm going to end up doing is going log of 2 to the x equals log of 10. All I've done there is taking the log of both sides. Okay? Well, why do we do this? Because there's a property that says if there's an exponent inside a log, you can move it out front as a coefficient. So this part right here goes out front, and I end up with x times log of 2 equals log of 10. Okay? Well, I've now gotten the x out of the exponent, so I can solve for it like we always do. What's happening to the x? It's being multiplied, so I have to divide. And what I divide by is log of 2. Right? Just like any other multiplication that we do division, we undo it and it cancels on this side, right? And then on this side, I end up with just x. On this side, I do log of 10 divided by log of 2, which I use my calculator for, and that's 3.32, and that is my answer. And again, you could check it. That means 2 to the 3.32 is approximately 10. That means log base 2, 10 is approximately 3.32. And again, where was the x? It was in our exponent. All right, last one. Now, x is in the exponent again, and this one's easier to see because it's in our more familiar exponential form, right? I can see there's an x in the exponent. So what I'm going to do is try to not common base. I'm trying to isolate it and then get a situation where I can log both sides, right? So at this point, sometimes you might get to a common base, sometimes you might not, meaning same base on both sides. This case, I can, spoiler alert, you won't. But maybe you isolate it and you do get that, and then you can go right back to that common base strategy. But if you can't, you can log both sides. So what we need to do is we need to first always get the part with the exponent by itself first. So I'm going to get this by itself first, right? And I'll rewrite the equation. It's 2 times 7 to the 9x equals 30. So, well, if I'm trying to get that by itself, what's happening to it? It's being multiplied, so I'm going to divide by 2 both sides. These 2's cancel, and I just have 7 to the 9x equals 15. Okay, so now I'm kind of in that same situation I was up above. I have no idea how to get that x out. I can't do this in my head. 7 to the 9 times something equals 15. I have no idea. Not a common base, nothing I can do. But I can log both sides. So I will log both sides. So I'm going to log 7 to the 9x and log 15. And just like in the last problem, my exponent, which in this case is 9x, comes out front. Okay? So I end up with 9x times log of 7 equals log of 15. Okay, so I need to get that x by itself. A couple things happening to it here. It's got a 9 multiplying by it. It's got log 7 multiplying by it. Let's get rid of them one at a time. So first I'm going to do what we did in the last problem, which was get rid of that log. So I'm going to divide by log of 7 on both sides. I end up canceling these two logs, and I have just 9x equals log of 15 divided by log of 7. In your calculator, you would get 1.3917. And I'm just going to say in the middle of a problem, you probably want to go out a lot. Just don't round too much in the middle. Otherwise, you won't get the right answer at the end. Okay? At the end, just pay attention to what the question asks you to round to. All right, 9x, get rid of that 9 by dividing both sides. And I get x equals 1.3917 divided by 9 is 0.1546. Okay? So, again, where was the x? Why did we do all that? The x was in the exponent. Okay? So that's it, right? You want to really pay attention to where is your x, right? Especially with this one and this one. The other thing you got to look out for is, do I have a common situation? Logs on both sides with the same base. Common bases on both sides. If I don't have the common situation, it's where are the x's? Is it in the base? Is it in the answer? Is it in the exponent? Okay? Good luck out there. Oh, I forgot to put the x here. This is in the exponent. There we go.